Okay, so today we have a pretty short video because we're just talking about a few things. We're going to be doing some activities in class with it. So the margin of error for this estimate. So we want to talk about the margin of error. Now notice that the margin of error is that piece that is added and subtracted from X bar to get our confidence interval. So essentially our confidence interval could be written as X bar minus margin of error E and X bar plus margin of error E. So our confidence interval can actually be written that way if we already know the confidence interval, or the margin of error. So a lot of times, most of you, I believe, are 89s, Casios, and Inspires. You guys are lucky because you actually do have margin of error that comes up on your the calculators for you guys, but some of you don't. So some of you just you get your confidence interval, and then you have to kind of work backwards to find your margin of error. So if you know your confidence interval, you can either find your margin of error by taking your upper minus your lower, hit enter, or put it in parentheses, and then divide by 2. Or you can just take the upper limit of your confidence interval and subtract your X bar, or your X bar minus your lower. Of course, all of these are the same thing because we know that when we have our X bar and we have E here, this is my lower, this is my upper. So upper minus lower is going to be 2 margin of errors. Upper minus X bar is my margin of error, and X bar minus my lower is margin of error. So 3 ways to actually find out what my margin of error is if I use my calculator to get my confidence interval. So again, this is the picture that I drew. My lower bound, my upper bound. So you'll notice a few things. The margin of error is half the length, width, whatever you want to call it. Some people like length of the confidence interval. Some people call it width of a confidence interval. I'm using those terms interchangeably with respect to confidence intervals. And the length + width of the confidence interval is twice the margin of error. So this kind of makes sense. You've seen margin of error. You'll say, they'll say something on the news and they'll say, well, it's about 26 plus or minus 5% margin of error. And they'll tell you something like that. And that's essentially what they're talking about. Or just 5 margin of error. Okay. So finding margin of error, real quick, I want to talk about one that we did last time. So in the last video, we did a problem about this one. So we did this problem with this data right here, and we were given a sigma, we were given an X bar, and I want you to note this piece right here, this is my margin of error. So this thing that got added and subtracted is my margin of error. So if I charted this out, this would look like 168.79, 219.37. In the middle is 194.083. So each one of these distances right here is 25.29. We'll just call it that. So I could actually go on my calculator, and since I was given this confidence interval, I could go 219.37 minus 168.79, hit enter. That's the length of my confidence interval. Divide by 2, and I have my margin of error, 25.29. So that is something you can always use to find your margin of error. You could always, I could have also done it a few different ways, but that's the way. To me, that's the easiest way to do it, even though it's, I guess, typing in more numbers. Okay, so now what we're going to talk about is a lot of times when you're getting ready to do a study, you don't really know what is a good sample size is going to be. Because if you think about it, a confidence interval, I mean, if you make it big enough, so remember your 99% gets huge. I mean, think about it. If you make a confidence interval that's sort of ridiculous. So if I can make a confidence interval that tells you that the average newborn baby is between 2 and 12 pounds, you're going to say to me, yeah, I already knew that. It just, we kind of, that's just a fact that we kind of know. I mean, most babies are born between 2 and 12 pounds. So yeah, definitely the average is going to be between there. So if you go and you try to say something like that, your precision is terrible. You haven't zeroed in on the actual mu. We don't know anything. But if I tell you that the average newborn baby is between 6.8 and 7.3 pounds, okay, now you've told me something. And the problem is we've constantly got precision and confidence at odds with each other. Because if we become more confident, we make our net wider, and we kind of make situations where, you're not telling me anything with the confidence interval that I didn't really already know intuitively. So the problem is we need to find a big enough sample size. It's really the only thing that we can control. So how do we go about doing this? So we want a margin of error that's small enough to really give us information, but we want to keep a certain confidence level. So in order to find that, we're going to use the formula, the sample size n equals our z, and this was use the chart. Remember the chart that says we've got a 90% confidence interval, so confidence level z. Remember this is 1.645. Oops, not 16. 1.645. 95% is 1.96. 98% is 2.33, and 99% is 2.576. Yes, I have them memorized because I use them a lot. So we're going to use this chart in order to find the z. Sigma has to be given. And this is our new margin of error. So the one we want. So whatever margin of error we want. And then we use that information to find n. Now it's really, really important to round up to the next whole number. Even if you get a really common one, 96.04 or something like that, that would be rounded up to 97, even though it is barely over 96. That means that you want to cover that margin of error. So it's going to be a little bit bigger or a little bit smaller, but you don't want to go over it because you want that margin of error. So this is just an explanation of everything that's in here. So let's do a quick example of this. So let's say on that previous problem, or let's go back to the IQ problem with the professors and their IQs. Okay, in the IQ problem, we had, remember that the X bar was 135. Well, we don't even care what that was actually. But we had an X bar 135. We actually had a margin of error in that one of 6.57. So let's say we want a margin of error of 5 points, and we want a 99% confidence interval. what sample size would we need? So what we're going to do is recall that sigma was 15. So we have our n. We're just going to fill in these pieces. Now, for a 99% confidence interval, we have 2.576 times 15 over. Now we want our new e. We don't put the old one we had. We want the new one. We want a 5. So we want our margin of error to be 5. And then we square this. So let's do this with our calculator. 576 times 15 divided by 5. We get 7.728. We're going to square that guy. Oops. And we get n has to be 59.72, and we have to round up. So n has to be 60. So the new sample size, in order to get this, should be at least 60. So instead of going to 20 professors, the researcher is going to have to, the college administrator is going to have to go to and test 60 randomly selected people, professors from the school, in order to get a margin of error as small as 5 and a 99% confidence. Okay. So the next thing we're going to talk about is, what about when population standard deviation is not known? So you had a pretty short video today, so enjoy that. We actually have a fairly short assignment today too, but everything else sort of goes together a little more. So I wanted to keep this one a little bit short. So enjoy that.